Maya.
And I'm Sun.
And we're going to talk to you about graphs. We're going to show you the different types of graphs, how they're used, and how to draw a really good graph so you get a good grade on your tests.
So hold on to your butts. In this lesson, we'll be talking about histograms, box and whisker plots, stem and leaf plots, dot plots, scatter plots, and ogives.
We're also going to show you how to use these types of graphs to determine shape, center, outliers, and spread. First, we're going to look at histograms. Histograms use consecutive intervals to indicate a continuous variable. The x-axis has intervals to show the given value, while the y-axis shows the corresponding frequencies. In this example, the continuous variable that we are looking at is the height of geese, and our intervals are 15 meters. It's important that our intervals stay consistent and have no gaps so that our graph shows an accurate depiction of our data. Specifically looking at this distribution, we can examine the shape, outlier, center, and spread. The shape of this distribution is unimodal, which means that it has one peak. It is also approximately symmetric because if cut down the middle, the right and left-hand sides look about the same. There do not appear to be any outliers, which means that there aren't any data points that seem to be very far away from the rest of the data. The center of this graph seems to be at about 56 or 55 meters, and both the mean and median seem to be at about the same place, which supports the fact that it is approximately symmetric. When we look at the spread of this graph, we can see that there is a range of 105 meters between the shortest and the tallest goose, because we can see that the tallest goose falls in the interval between 90 and 105 meters, whereas the shortest goose falls in the interval between 0 and 15 meters. Now let's look at box and whisker plots. To make a box and whisker plot, we must first start with a number line to show the range of the data. After that, we mark our minimum, our maximum, and our median. Between the minimum and the median comes the first quartile, and between the median and the maximum falls the third quartile. We draw a box connecting the first and third quartiles and separate them at the median. We also draw whiskers out to the minimum and the maximum. Any outliers are represented as a dot. The range of a box and whisker plot is the entire spread of the graph. The inner quartile range, or middle 50% of the data, is between quartiles 1 and 3. To determine if a data point is an outlier or not, we must multiply the inner quartile range by 1.5. We then take this value of 1.5 times the inner quartile range and subtract it from the first quartile. If our data point is below this value, then it is an outlier. In the same way, if our data point is 1.5 times the inner quartile range above the third quartile, then it is also considered an outlier.
Next, we'll talk about stem and leaf plots. As you can see, a stem and leaf plot resembles a histogram on its side. A vertical line separates the two parts of the stem and leaf plot, the stem and the leaf. The stem represents the first digits of each data point, and the leaves represents the last digit. For instance, in the example below, the data point 108 will be represented by 10, vertical line, 8. Each digit on the right side, or each leaf, represents a single data point. However, a stem and leaf can also be two-sided. In this case, the stem would be in the middle, and leaves for two different data distributions would be on either side. A two-sided stem and leaf plot can be used to compare two different data distributions and can be used to easily compare things such as median and spread. In the examples shown, each line in the plot represents groups of 10. For example, the stem 10 holds data points from 100 to 109. This need not be the case, however. You can set the intervals to whatever you'd like as long as it is consistent. For instance, you could use an interval of 5 and have two stems of 10, with the first representing 100 to 104 and the second representing 105 to 109.
Now we're going to look at dot plots. To make a dot plot, we're going to start with a number line to show the range of the data. In our example, you can see that the data ranges from 10 spots to 24 spots. Each data point is a dot, and if the values are repeated, then a dot is placed above the previous value to show an observation of a repeated value. With a dot plot, you can determine the spread, shape, center, and if there are any outliers quite easily. In our example, it seems that the approximate center is 18 spots because there are 9 observations of leopards with 18 spots. We can see the range of our data because that is the number line, and it shows that the data ranges from 10 spots to 24 spots. We can also easily see outliers because the leopard with 10 spots is quite far away from the majority of the other observations, so we would say that it is likely to be an outlier. More than that, we can see that this dot plot is unimodal because there is only one peak. Still, dot plots aren't very useful for large data sets because counting hundreds or thousands of observations would be quite difficult on a dot plot, as would drawing in hundreds or thousands of dots. Now we're going to look at scatter plots. Scatter plots are great for showcasing bivariate data, namely values for two variables, and we do this on a Cartesian plane. The x-axis shows the explanatory variable or the independent variable, and the y-axis shows the response variable or the dependent variable. Each data point is represented by a dot in the scatter plot which corresponds to a given x and y value. When looking at a scatter plot, we're going to look at three main things: linearity, slope, and strength. The linearity of a scatter plot shows whether the data is curved or sticks to a line. If it sticks to a line, then it's linear. The slope refers to the change in the response variable for the change in the explanatory variable. For example, if the response variable increases as the explanatory variable increases, we would say that our data has a positive slope. Next, when we look at the strength of our data, we would see how scattered the data is or how spread out the points are. We use this to show a correlation. If there is a strong relationship, linear or nonlinear, then we would say that there is a correlation between the explanatory and response variable. However, in our example, there doesn't seem to be a correlation between the amount of time spent on the internet and the number of cat videos watched because the data is very spread out. Still, our example does give us a good way to look at gaps and clusters in our data, which are one thing that scatter plots are very useful for. Now, it seems that there is a cluster of data around 20 hours spent on the internet and about 130 cat videos watched.
The last type of graph we'll be talking about is the ogive, or the cumulative frequency plot. To understand how the ogive works, imagine a histogram that, instead of showing frequency for each interval, showed cumulative frequency. That is, each interval showed its own frequency as well as the combined frequency of all the data points before it. If these intervals became smaller and smaller and more numerous, the tops would make a continuous curve, like the ogive, where each value on the x-axis has a cumulative frequency equal to the total number of scores that are less than or equal to that value. The fact that an ogive shows cumulative frequency makes finding a distribution's median, Q1 and Q3 very easy. The value of the cumulative frequency of 25% is the Q1, the one with 50% the median, and the one with 75% Q3. This can be seen visually in the example shown. The quartiles are the corresponding x values to these percentages on the y-axis.